Hello guys, this is the review for the Unit 4 exam, which you'll be taking tomorrow. So I'm going to go over a couple of questions in the review, one of them being the free response question. So just looking at this, we have three different graphs here, all using the same data, difference being, if we look at the actual graphs, some of them are in log, so here's log age versus log price. Age without moving the log, and log price on the y-axis, and here this would be just a regular linear relationship between age and price. Okay, and so remember that what we're looking for is which one gives us the best linear relationship. And so although if you look at the actual plots, you could arguably put up a decent linear regression line. I mean, if I drew a line here, that looks okay. If I drew a line here, I mean, it looks better. And then on this one over here, again, it looks okay. The line's not horrible. But when I start looking at the residual plots, like I see over here, they gave you both the data plot and then also the residual. Here I do start to see a pattern. And it looks more U-shaped right here. Okay, so remember, on a residual pattern, you're really looking, if a predicted, a y-hat equation works for that data, you really shouldn't see a type of pattern in the residual plot. So this one, I start to see a U. So using just a regular linear residual line is probably not the best point for that. And then that's actually going to be one of our questions. This one here, I do see that it's fairly random. And so this one looks a little bit better. And the last one right here, again, I start to see a pattern, which is also U-shaped, but in a backwards form. So this one is probably also not a proper regression to represent the data. So let's go ahead and start going into these questions. So number one is asking, explain how the information provided suggests that a linear model may not be appropriate for describing the relationship between car age and price. So again, guys, if I just look at it, this is the price versus age. Okay, so this is the way my graph looks. So the reason I can tell that this is not a good fit, I would say something like, oh, here's the, okay, so this is actually curved a little. Looks something like that. Okay, so we could put that there is a curved relationship between car price and age. Okay. As seen on the scatter plot. Okay, so this would indicate that a linear regression or linear model may not be appropriate for the data. Okay. You can keep going on. We saw that in the residual as well. We definitely see the pattern here. So that is really also telling me that there's that this does not work. So I guess we should have been a little bit curve relationship in the scatter plot here. Oops. So so additionally the regression plot. Actually, not regression, residual. Additionally, the residual plot also shows a U-shaped pattern, also indicating that the linear model is not may not be appropriate. So, moving on to question number 2. So, would an exponential or a power model provide a better description? Well, this is where we have to start remembering what an exponential and power model look like. So, I went ahead and wrote them out here. So linear is what we were talking about. This is just regular x, regular y. Power model, if I'm looking at these problems over here, would be on the x-axis I'd see log x, log y. Logarithmic would be log x and regular y. And exponential would be x and log y. So let's look at what we got here. So here I see that this is regular x and log y. Okay, so that tells me that this one is an exponential model. So this was exponential. And this one here is log x and log y, so log in both of them. So that's looking like this one right here, which means this is a power model. And they didn't give us one that looks like a log model. So to answer the question over here, do we use an exponential or power model? Well, which one gives us a more random residual or a more linear looking set of data? Well, it's going to be this one. So the exponential is the model that should be used. So so the model that provides a more linear relationship should be used. Okay, and so the scatter plot the scatter plot that represents the data as log price versus age is linear. I should say not is, this appears to be linear. And the residual plot shows a random scatter. And there are no obvious patterns. So moving forward, guys, now it's just now that we've been able to tell which model is the best one. So this one's given the equation of the model that you choose in question 2. Use the transform using the transform variables. Okay, so give the equation using transform variables. So here, okay, we're looking at these right here. So we know that age is the x, so just so that we're all on the same page, this is representing the x. So this number right here is actually the slope. So this is what we need to remember about these. This is the slope, and over here this is the y-intercept. Okay, so Notice that we don't see the word log in these here, but I do know that the log is in the y because of the way the data is represented. So when I write this, okay, I can do it one or two ways. So I'm going to go ahead and just write it with the hat. Well, let me go ahead and write both ways. So you can write it like this, just straight up, y hat is equal to, remember we're doing a plus bx here, so this is the y hat equals a plus bx, is 1.43723 minus 0.090652x, and you need to indicate here that x is equal to the price. Excuse me, not the price. X is equal to the age of the car, and in this case, log y hat would be the log of the price of the car. Okay, but I would suggest you write it like this, guys. Since I already know the y is the log, just put log y like this and put this whole thing over a hat equals 1.43723 minus 0.09652 x, and again you do need to indicate what is what, so x is here is equal to the age of the car, and y in log y hat is equal to the log of the price of the car. So it is somewhere in this equation that needs to be indicated. If you don't put that y is this and x is that, it is going to be wrong. Okay, so even if you have everything else right. So I mean, you could have also, there's a third way you could have written this. So log of price is equal to, and then it's going to be the same equation, 1.43723 minus 0.09652 multiplied by the age. That's okay, and then you wouldn't have to write this because you went ahead and just wrote it straight into the equation. So either is fine. All three of these are fine. I suggest you do either this one or this one, but it needs to be indicated what is the x and what is the y, though. That is important. So last question, using my model from question 2, predict the price of a 5-year-old Taurus. So log of y is equal to 1.43723 minus 52, and then the age, the x is the 5. And for me personally, guys, I would just go ahead and use nsolve at this point. So y is going to equal, let me get my calculator out. It's taking a little while. And we could use our log rules also. I mean, I still need the calculator for it, but it could. Okay. So if I wanted to use the log rules, guys, I could. So I just put 1.43723 minus 0.09652 times 5. So this is what it equals. So log y hat is equal to 0.095463. Okay, and now to get rid of the log, well then I'd find the base. So here, if I don't have one, it's 10. So base 10. So y is equal to 10 to the power of this. Okay, so it's equal to 9 point. I think I wrote something wrong in here. Oh, yep, I wrote it wrong. Forget a 0 in there in the middle. Okay, so this number was 0.98397. My mistake. Okay, so the answer here should be 9.63762. But remember, this hat is the price, but this is in thousands, so I would move this 4 spots. So 1, 2, 3, 4. I'm sorry, 3 spots. This is in thousands, so 1, because this is the tens, the hundreds, and the thousands. So the actual price should be $9,637.62. And just so we get on the same page here, I could have also just plugged this straight into the nsolve. So menu 3.1 log and I end up with the same number. So either or is fine. So this is the review, guys. There's gonna be one more video, 2 more videos, I'm sorry. One more that I make and another one that I need you to look at on your own. So look for them, and I will see you all tomorrow.